All right, let's take a look at it. Math 1030, Exam 1 Review. This covers two modules, and each module broken up into two parts. The first part, situational rounding rates and proportions. The second part, percents. The first part of module 2, measurement, and the fourth part, problem solving. So the first module, we have some questions, starting with question number 1. Suppose that there are only 100 milligram options for measuring a certain medication, and it is important not to over-medicate a patient. So a 295-pound man can have 1,500 milligrams of a medicine in a day. How much should a 165-pound man be given in a day? All right, so we are only 100 milligram options, so we're going to be rounding to the nearest 100. And the fact that we cannot over-medicate means that we're always going to round down. This is a situational roundings where we have to round down, rounded to the nearest 100. Other than that, we can solve this as a proportion. So I'm going to set out my proportion by looking at the units of the ratios involved. What they want to find is how much should a man be given in a day? So that's the medicine. So I'm going to do the milligrams on top and the pounds of the person on the bottom. That's going to be the format of my ratios. So now, how much should I can put X on the top left. This will make it the easiest to solve. The 165-pound man. And on the right, we have the milligrams, 1,500 milligrams. And on the bottom, for a 295-pound man. So this is our proportion. And all we need to do is multiply by the 165 pounds on both sides, and we can solve for X. What this does is it leaves us just X equals on the left. And on the right, we can reduce the pounds, and the only units left will be milligrams. We just need to go to a calculator. I'm using the calculator recommended for this class so that you can see all the keystrokes for it. We have 1,500 times the 165 divided by the 295, 838.98. And that's approximation. We now have to figure out the rounding. So if we would, let's say the closest 100 milligrams there are to this, we could go down to 800 or we could go up to 900, but we can't get an 838 milligram size because that's not how this medicine is divvied up. This would be over-medicating. This is what we need to do to make sure that we do not over-medicate. And that would be the answer. All right, I hope this makes sense. Let's look at question number 2. A 40-ounce bottle of dish soap sells for $2.78. A 41-ounce bottle of dish soap sells for $3.15. Well, it's pretty clear which one's more expensive, but we can look at the unit price. The unit price is dollars per ounce. So we want to create a dollars per ounce situation. We have the first one, the dollars on top. That's why I like to write the ratio units so I remember which one goes on top when I'm doing the problem. 278 for 40 ounces. And the other one would be 315 for 41 ounces. And they want us to round to 4 decimal places. Okay, prepared. 278 divided by 40. That is already 4 decimal places. The units are dollars on top and ounce on bottom. There's the unit price of that one. The second one, we do have to round. 4 decimal places, 0.076, and then the 8 would stay at 8 because the next number, the next digit is 2, it's less than 5. Okay, so we can now see the unit price. This is approximately 7 cents an ounce, and this is closer to 8 cents an ounce. So the second soap is more expensive. But we have our two values. It's easy enough to compute. And then which of the two is the better deal? Our top one was the better deal. And that completes that question. Unit rate, dollar on top and measurement on bottom. Could be ounces, could be gallons, could be feet, etc. Question 3. At 3 p.m., a man 141 centimeters tall casts a shadow 143 centimeters long. At the same time, a tall building nearby casts a shadow 172 meters long. How tall is the building? All right, how tall is the building is what we want to find out. So I want the building or the object on top. And then that makes the shadow length on the bottom. So that's the form of the ratio as I'm going to use. How tall is the building? X. Its shadow is 172 meters. This is proportional to how tall is the man, 141 centimeters, and how long is his shadow, 143 centimeters. And what we have to do to solve is multiply by this 172 meters. I like to set up these proportions with X as the top left so that it's just one step to solve. So I need to read through the question and find out what they're asking about. And then I want that unit to be on top. How tall is the building? That's the object. I'm calling that X. And then we know its shadow, that's on the bottom. That's how I set this up. I look to see if I can set it up that way for ease of calculation. All right, so what happens here? We can reduce units like that. Here, the centimeters reduce on their own, and our final unit will be meters, which is exactly how we would expect this building to be measured, not in centimeters, but meters. So we did not have to do any unit conversions on this. Rounded to the nearest whole, approximation not equal, and now 141 times 172 divided by 143. 169.59 rounded to the nearest unit, nearest meter, the 9. You look to the right, 5 is bigger than, it's 5 or more, so the 9 has to go up. So 69 goes up to 70. We're looking at 170 meters. There we go. All right, next one. If Chi walks 5 miles in 40 minutes, then Chi will walk how far in 1 hour and 30 minutes if she walks at the same speed the whole time. So we have to assume the same rate in order to set up a proportion. Why this previous problem worked is the rate of the shadow's growth depends on the sun, and it's the same sun and the same time of day hitting the man and the building. And so that's why we can assume the same rate of shadow length. Our previous problem, that was units, there we go, this man and the medicine. Here we're assuming the same rate for all men. I don't know if that's viable or not, but that's what we're assuming by setting up a proportion. If you set up a proportion, you're assuming the same rate for both instances of whatever you're looking at. Might or might not be true. In this case, they told us it's the same rate. All right, so what did they want us to find? She will walk how far? So that's distance. The units for distance in this problem is miles. And the other thing is time. Now we have an issue with an hour and minutes, and then here minutes. So both of them have minutes, and then this one has hour. I want to go to minutes for my setup for the ratios in my proportion. It does require me to look at 1 hour and 30 minutes and compute 1 hour, 60 minutes. So that would be 90 minutes. 1 hour and 30 minutes. All right, so how far will she walk? X in 90 minutes. The proportion, we know that she walks, she, he, I'm not sure. They walk 5 miles in 40 minutes. Okay, to solve, we multiply by the left denominator. It will nicely reduce, leaving us just X equals. Proceed to our calculator. 5 times 90 divided by 40. 11.25. And that's exact. There's no rounding. So that so X equals 11.25 and the units miles. Now let's see if they wanted it rounded. Round to the nearest tenth of a mile. So the 2 would be an issue. We look to the right, 5 raises it up to 3, 11.3. Oh, nice. Question number 5. Veronica bought a new car for $28,740. She was surprised the dealer then added $1,005.90 in taxes. What was the sales tax rate for this purchase? All right, so there's formulas for percent of problems. We can do this as a proportion. It's not a bad way to go. Give me one moment. Okay, as I was saying, you can solve these with proportions, but there's a formula, and it is part over whole, and that'll be a decimal, times 100 will give you the percentage. What I like about this formula is this is great if you want to work out the percent. And in this question, what was the sales tax rate? That's the percentage. And they even have the units percent. So we just need the part and the whole. The part's always a smaller number when dealing with percent of, because you can get no more than 100% of. So the part is the smaller number. The whole is the whole price of the larger number times 100. And let's look and see what we get. First off, the units reduce, so we won't have a unit, but we actually do have the unit, that's the percentage. So you'll see some people have the percent here as well for the units. Oops. Go, divide by 28,740, and then times 100, and we have 3.5%. Simple. Some people like the proportion. The proportion would look like part over whole is the format of the ratios, and it would be 1005.90 and 28740 equals the part is an unknown percent and the whole is 100. That works as well. One step, solve for X, multiply by 100, exact same operation. Okay, now, is there another question with tax? That's an increase. Let me just say this about this in case we need it or not. You can take this same formula and solve for different pieces. So this one's solved for percent. It's great if they say, what's the rate or what's the percent? Maybe you want the part. So if we were to divide by 100 and multiply by the number whole, we would get part equals percent times whole. divide by 100. Again, we put the whole up, the 100 down, left part. Easy enough to do. This would be great if your problem gave you the percentage and gave you the whole piece and you wanted to know what part that percent represented. And then you can also solve for whole. To solve for the whole, you need to move the 100 up and the percent down, and that would give you whole. Move the 100 up, so that's part times 100, and then we move the percentage down. This would be great if you knew the part and the percent it represented, and you wanted to find the whole value that it was. Okay, so all three of these formulas are based on this first one, which is the part divided by whole, which is just a decimal, times 100 gives you the percent. And then you can quickly move things around and get these other versions, which are very helpful in other problems. Okay, question number 6. The sales tax rate for a local county is 9.2%. If an item costs $105 before tax, what will be the final price paid, including tax? Okay, so there are two basic approaches. What we want is the tax. That would be the part that we have to pay. So if we worked out with the part one, we could get part, that's the tax, equals the percent, 9.2 times the whole value, 105, divided by 100. And this will give us the part that we owe to the government in tax, $9.66. So you can still use these formulas to work out specific percentages, but then we have to have the total price, and that would be the original price plus the tax. And that's plus 10 would be 115, a little less would be 114.66. Of course, we have our calculator to do that kind of stuff, but here we have 114.66. So this is a two-step approach. We find the percent, in this case, how much tax do we owe, then add it to the original price. There's also a one-step approach, which I favor. And let me explain how that is first off. So here is the price that we're paying, the full price of an item. Then we're adding on to that tax, which is 9.2%. And if we look at the entire price we end up paying is 109.2%. Now, percent literally means divide by 100. So if we divide by 100, we get 1.092. I call this the multiplier. So if we take our original price and we multiply by the multiplier, it will apply a 9.2% tax, but it'll also compute the original price plus that all in one step. So 105 times 1.092. There's our final answer. One step in our calculator. We don't have to do two steps, just one. So how do we get the multipliers? I really like this format for the multipliers. It makes a lot of sense, but there's also formulas like for an increase, like tax. The multiplier is 1 plus the percent over 100. And if it's a decrease, like a coupon or a sale, then it's 1 minus the percent decrease over 100. So a little formula like that can also be worked. So for ours, 1 plus the tax rate, 9.2 divided by 100, and you'll see it's the exact same multiplier that I worked with on this problem. So there's formulas for the multipliers, there's visual concepts as well, but I prefer to work with the multipliers. If you multiply by a multiplier, it makes the change, like adding tax or taking off a coupon. If you divide by the same multiplier, it undoes that change, which is sometimes what you need to find out. Like question 7. This week, Santiago got a promotion at work that came with a 6% pay increase. If now his monthly salary is 3,127, how much was he making before the raise? So the 3,127 is after the raise. So we would look at the 6%, and this is a raise. So here we have 100% and an extra 6%. So that's 106%. Which gets us the multiplier 1.06. Some of you can probably just think through that really quickly and go straight from the 6% to the 1.06. You can also do it this way. But the multiplier involved with a pay increase, a percent pay increase, in this case is 1.06. Now, there's really only one thing we can do. Well, there's two things, sorry, we can do. We can multiply by the 1.06. And what that does, and by the way, it's wrong on this problem, but what that does is it applies the change. So if we do this, this will give this salary a raise. Clearly not what he had before his raise. Now, if instead we divide by the multiplier, it undoes the raise. So when you work out your multiplier, if you multiply by it, you are affecting the change. If you divide by it, you are undoing the change. In this case, we knew his after value. We wanted to undo it and find his $2,950. Okay. Question 8. So again, why I prefer the multiplier approach is it makes it really easy to undo situations like we just saw. Something else, question 8, we have an original cost. Now we have 45% off. We've got to get to the multiplier. We also have a 25% off coupon, another multiplier. And then we have a tax. That's another multiplier. There's 3 multipliers involved in the transaction of this purchase. Now, if we just went with the one, so let me do it visually first. Let's say that's 100%. This time we're taking 45% off. What we need to figure out is what's left to pay, and it's 55%. 55 plus 45 is 100. And 55% is 55 over 100. It's 0.55. So that's the multiplier for this discount. A discount multiplier always starts with 0. It's a number less than 1, whereas a tax or an increase or a tip will be a number, it's an increase, it's a number larger than 1, so it'll be 1 point something. We also have the formula, 1 minus percent over 100 for the discounts. And that would give us 1 minus, let's do that one as well. Formula versus concept, they're both very valuable to know. There's our 0.55. So 25% off. Oh, something else. With these calculators, you can just go back and re-enter something so you can save your keystrokes a little bit. 25% off is a 0.75 multiplier. And a tax, it's a plus, and 8, delete one, there we go, 1.08. So these are the 3 multipliers involved in the 2 discounts and the 1 increase. To get the final price of our $1,149 purchase, we just multiply, we're applying all of these coupons first, sales and coupons, and then the tax rate. You could rearrange the factors because multiplication is commutative. 2 times 5 is the same as 5 times 2. But whatever order they gave them to me, that's the order I multiply. We have 1,149 times 0.55. There goes 45% off. Another 25% off. And 8% tax. Final answer, $511.88. This is a situational rounding. We're dealing with money, so go to the nearest penny. There we go. So you work out the multiplier for each percent increase or decrease, and then multiply them all together with the initial cost. You get your final cost. It's a very efficient approach. Whereas the two-step approach would be a lot more work because it would be 2 steps for the first percent off, find the discount, subtract the discount, then find the discount, subtract the discount, then find the tax and add the tax. It would be a much longer process. But that doesn't mean it's a bad process. Okay. You take a job with a starting salary. This job guarantees a raise of at least 5% per year. You can assume that in 3 years, you'll be making how much money, at least. All right, so here we have a 5% increase. We get to the multiplier 1.05. By the formula approach, or 100 plus 5 is 105, and divide by 100. Hopefully that's clear now. We get to the multiplier. If we multiply by the multiplier, so let's see, you can assume that in 3 years, you will be making, and you start there. So in 1 year, so this will be in 1 year. If we do another multiply, that'll be in 2 years. If we do another multiply, that'll be in 3 years. So if you want to apply the same increase 3 times in a row, it's 3 multiplications. And some of you might choose to do it this way instead. Doesn't matter. Let's take a look. We get the units are from that term. Okay, 9,600.18 when we round to the nearest penny. And again, if we did 77,400 and multiply by 1.05 to the third, it's a little bit faster keystrokes, but the same operations involved. See how we did. There we go. Again, these multipliers are very efficient. Highly recommended that that's one of the things you master out of this course because they're so useful. Question 10. This is a weighted average question. Suppose you have a Canvas grade of 78.3% before the 4th exam. If every assignment is already graded and the 4th exam counts as 15%, that's an if statement. Oh, there's the comma. What is the highest course grade you can earn? So the situation we find ourselves in is here's our course grade, 100%. There's still a test left over that's 15% of the grade. That suggests that we've already potentially earned 85% of the grade. We've gone through 85% of the course graded objects. There's still 15% more, which is all on one big test. Okay, how did we do? We have 78.3%. So let's say that's 78.3 over 100. And these percents, this percent, you can think of as percentage points, but they're actually the unit that we're going to stick with this problem. So think of it as like it is an inch. I'm not going to do that divide by 100. You could, it's possible, but it's a little more confusing. Okay, so basically the 85% is how much we could have earned, and we earned that ratio of the 85%. So if we just look at that piece, of the 85% points we could get, we've earned 66.555. Now, if you wanted with the 85 to do 0.85, then we can see we've earned 0.66555 of the one full possible grade we could get. So it's a little harder if we do the 85% as a percentage in decimal form. Whereas here we can see that we've earned 66.555% so far of the entire grade. Okay. We don't know on this last exam what we're going to get. But it does say that what is the highest course grade? So what if we got 100 on it? Then that would be plus of the 15% left over. Let's say we got all of it. That would just be plus 15 and 66.555. And just do that to get it back to the percent. There we go. Plus the 15%, 81.555. 81.56%. That's the best we can do. Not bad though. Still a B minus. Enough to get your quantitative reasoning gen ed out of the way and possibly get your degree, associate's degree out of the way. That's good. Okay. What if you only wanted a 73? So this piece right here is how we worked out what if we got a 100 on the final grade. Okay. Now this part, what is the minimum score? We don't know what that is. So we'd have 85% times 78 over 3 over 100. However, we can also just replace that with what we know it's equal. So that'll be a little bit easier. Let's go with 66.555, the grade we have going in, and then 15%, but we're getting an unknown score on that. We're trying to find out what score will give us a minimum of a 73. So instead of knowing everything on the left side and working out the right side, now we know the right side, what we're trying to get, and there's a variable on the left side. Okay, so one step at a time. The first step would be subtract this percentage. Doesn't have an X in it, so I don't want to have it on the X's side. This is a percent, this is a percent. They're all nice percent numbers. I'm just going to write it for now. You'll see why in a second. Okay, and then we need to get rid of the 100. That'll do it. Well, we also need to get rid of the 15. That'll do it. The units actually all reduce. This is a percent, this is a percent. All the units are gone. So we're just going to get a number out of this. X equals, we have 73% minus 66.555%. Let's just even not worry about the percents since all those percent signs are going to reduce. Let's work this out. So parenthesis 73 minus 66.555 parenthesis and times 100 and divide by 15. What score do we need to get on the fourth exam to get a 73%? We need a 42.97. A very high bar. And they did say nearest whole percent, so that would be 43%. This is where I have to go back and read the rounding. Okay, and what was special about this is that we wanted to find out what score would get us to 73. So let's just highlight where that 73 ended up. Because if we can do this well, to get an 83, we just need to replace the 73 with an 83. And with our calculator, the way I set this up, oops, well, we can just go change that 73 to an 83. And we need a 109.6%. That's not happening. Rounded to the nearest percent, because that's what they asked for. We need 110%. It's not possible, but that's what we need. So it's not possible to get a B. So if we have a 78% going in, no matter how good we get on that last exam, we can't pull it up to a B. That's why I leave everything open and give you the optional final exam in my class so that you can get some points back and maybe still get that B. What if we wanted a 93%? We can't get a B. We need 176 points percent. So we're definitely out of the realm of possible for both a B and an A. I'll round it to the nearest percent. There we go. Okay, so sad news, we are not getting an A either. Oh, did it say round up? Oh, yeah. So now this is a situational rounding. I shouldn't have just rounded. I should have thought through this. If you want an A and you need an A, you need to pass the 176.3. Anything better than that will be an A. Anything lower than that will be an A minus. Well, 176 is lower than that. So I actually have to go up to 177 to make sure I get an A. Now it did say round up, and so I shouldn't have had to think through that, but I missed thinking through that. And then I had to go back and reread that. It's kind of sad. Oh, well, that's the last question in the first module review. Next question is on module 2 review. Augustina is planning to go paddleboarding this weekend, wants to know the water temperature. Lake temperature is reported 8.5 degrees centigrade or Celsius, and after a few sunny days, it's supposed to warm up 1.5 degrees Celsius. What will the water temperature be in degrees Fahrenheit this weekend? Now, we do have this unit conversion table, tiny thing here, but this will be included on your exam, and it includes these formulas. Let me copy it down. Degrees Fahrenheit equals 9/5 times degrees Celsius plus 32. All right. Now, we're starting at 8.5 degrees Celsius, but then it's going to warm up by 1.5 degrees Celsius. Little quick calculation, that's 10 degrees Celsius. So we need to plug that into our formula, and we can find the degrees Fahrenheit that that's equivalent to. We actually don't need the units here. The units are involved in the problem, but we haven't given those to you, so it'd probably be more confusing than not. All right, let me use this calculator's true abilities and use the fraction button. The nice thing about the way this calculator is set up, and that's in the mode math print, is when you have it set up, you can look at your work on the calculator and on paper and know it's perfect. 50 degrees. Okay, so this coming weekend is supposed to be 50-degree water. Be nice. Question number 2. During an eye exam, the doctor measured the distance chastity to can naturally focus to be 10 centimeters. What is that in inches? All right, so we have 10 centimeters. Put that over 1 because unit conversion is all about multiplying by forms of 1 of the form a fraction where the top and the bottom are the same value. In this case, we look up and it's tiny here, but there's 1 inch equals 2.54 centimeters. I need the centimeters on the bottom because I need these units to reduce. So that forces the 2.54 down and the 1 inch on the top. And our units will just be inches. We want this rounded to the nearest tenth. And on our calculator, if the number's on top, if it's the first number, just enter it in. If it's on top, you proceed it with the times. We don't have any other number other than 1. I guess you could do the times 1, but it won't change the value. If the denominator is where the number is, proceed it with the division sign. So we don't need it for the 1, but 2.54 is also in the denominator, so proceed it with the division sign. We could have just gone with 10 divided by 2.54 as well. We don't need to enter those ones. I just wanted to show you the notation so that you know if it's on top, have a times before, if it's on bottom, have a divide before. Okay, so 3.937, that would be 3.93. So just 3.9 inches, I believe. They wanted the nearest tenth. 3.9 inches. Awesome. Question 3. The height from the floor to the ceiling. Well, there are some spelling mistakes in here. Well, that's embarrassing, but this isn't an English class, so I guess I'll look the other way. 9 feet is the height. We want that in meters. Excuse me. 9 feet. The only conversion that's in for distance in between the US system, there's 2 of them. One's an equal sign, 1 inch is 2.54 centimeters. The other one's an approximation, so it's not as good of a measurement. 0.621 miles is 1 kilometer. So I really want to use this 1 inch and 2.54 centimeters one again. It has the best chance for perfect or the best precision. In order to use it, I need to either get inches involved or centimeters involved, and I'm in feet. So I can get, see, I need feet in the bottom, be 1 foot, it's 12 inches. That allows me to reduce the feet. I'm now in inches. I need the inches in the denominator, so that's 1 inch. That'll be the 2.54 centimeters in the numerator. And now I'm in centimeters. Also in the table, it says that there's 100 centimeters in 1 meter. This table will be included on your test. Okay, now the 9 starts out, the 12's on top, so times 12. The 2.54 is on top, so times 2.54. And the 100's on the bottom, so divide 100. 2.7432. And the units, meters. Let's see what they want. To the nearest tenth, that should be 2.7 meters. All right, making great progress. Look at the next one. Question 4. Tyrone and Himari are making a new garden box in their backyard that measures 4,904 cubic inches. So we have the size 4,904 inches cubed. Put it over 1. We want to know the size in cubic feet. You need to get to cubic feet. The issue with the conversion table is capacity is cubic feet is the volume, but I look through here, there's a cubic feet right here, but that gives us to gallons. It's not going to get us to cubic inches. So I don't see anything with cubic feet other than there. So that's not going to help us. But what does help us is I know that 12 inches equals 1 foot. Now that doesn't reduce the cubic inches because this is a distance conversion. However, if I cube the entire thing, that's 1 cubed is still 1. Now it's cubic inches. Now those reduce because that's inside a cube. And our answer will be feet cubed or cubic feet. Now we just have to go to our calculator, 4904. The 12 is on the bottom, so divide, and it's inside a cube, so cube it. Let's make a very efficient approach to use the conversion factors that you do know or that are given to create other ones. So I will do the same way to go from a distance conversion to a area with a square, or in this case, a cube, to get volume conversion. 1 decimal place, 2.8. There we go, 2.8. Nice. Number 5, you need a new fridge for your house. You make a measurement, the space that you have for the fridge, and you go to the store, you measure a 3 foot, 1 inch space. Well, again, multiplying by 12 from feet to inches, and you can see that with 3 feet over 1 times 1 foot equals 12 inches. Nice conversion factor. 36 inches plus 1 inch. 37 inches is how far you measure the space for the fridge. You go to the store, and the fridge at the store measured 100 centimeters. Okay, we don't know what that is. So we continue to convert this inches with 1 inch is 2.54 centimeters. So how big is this 37-inch space? 93.98 centimeters. That's how big of a space we have. The problem is, so that's, they wanted to round up, round to 1 decimal place. So that would be 94.0. I would not round up because something that's exactly 94 won't quite fit. And so don't buy that. So I would round down. I'd rather have a little bit extra space than try to shove in a refrigerator in a spot that it doesn't go. But they gave us the rounding rules, even though they don't make much sense. How many centimeters wide is the space in your home? 94. Will it fit? Will this fridge 100? Clearly no. It's too big. It's close, but too big. All right. Question number 6. Pizza parlor. Local pizza parlor is selling 2 different shaped pizzas. So we have, 2 square shaped pizzas or a circular pizza for the same price. Okay, what we know is the square pizzas are each 8-inch by 8-inch. We know the area formula. This is also provided on the test, is LW, 8 times 8, 64 square inches. And this one's also 64 square inches. And so 64 plus 64, 128 square inches. That's how much pizza we get with the 2 squares. With the circle, what we're given is the diameter is 14 inches. The formula for the area of a circle is also given on the test. It's pi r squared, but we're not given r. R is half of the diameter. That would be 7 inches. Half of 14 is 7. So we have pi times 7 inches squared. And funny thing happens when we use our calculator with the pi button. it gives us an answer with pi, which doesn't really help. Some of your calculators will just give you decimals, but there's a button, this double arrow button converts between pretty type math print like this and the decimal version. So the circular pizza is considerably larger. Well, quite a bit larger. It also has less crust, so it has more of the good insides. Unless you like the crust, then maybe you want to go a little bit smaller pizza, more crust. But that's a judgment call. If they're the same price, that would be 128 and 153. They want one decimal, so 153.9 square inches. Then the one large round pizza is a better, it gives you more pizza. Okay, question number 7. You read online that a 15-foot by 20-foot brick patio would cost about $2,275 to have professionally installed. Okay, now a patio would not make sense to be measured as a cubic foot. That's a volume. It wouldn't be any sense to call it just a foot, because that's a length. Patios are in square feet, the area of the patio. So we have to work out the area. Height times width. So the 15 by 20, the area would be 15 feet times 20 feet. 2 times 15 is 30 with a 0, 300 square feet. Of course, you use your calculator, that's fine. And that one costs $2,275 to have professionally installed. That could be a conversion factor, or we could use that in a proportion, either way. But we're trying to figure out how much it would be if they charged at the same rate, which is an assumption. We don't know if they'd honor that same rate. What would they charge? So this is an estimation. We do have length times width. $364 square feet. So it's not much bigger, so they shouldn't charge much more than this. To solve it, we could set up a proportion. Just for a change, you could do a unit conversion as well. X, the unknown cost, over the square footage. That would be the form of my ratios. Unknown cost over the 364 equals the known cost over its size, 300, and then multiply by 364. I did not include units. We can look at those units as well, just so we can see it's all working out nice. The only unit left over is the dollar sign. We have 2275 times 364 divided by 300. Approximately. Now we're going to go with money rounding, $2,767.92. That would be an estimation. So that way we go in and ask them how much it would be. We have an estimated price. Here's dollar. I don't know what happened. I must have typed something in wrong, because that is not what we got. Let me double check. First off, 15 times 20 is 300. Did it cost 22.75? Yes, it did. 1520, 14 by 26. Okay. 14 times 26 is 364. I typed in. Oh, I see it. I put 365 in the calculator. I should have put 364. Huh. Well, if I graded this, I would go through this and see everything was right. And then I put a little question mark there because it was clearly a calculator error, and I'd give you 5 out of 6 points. So just so you know, I don't know what your teacher will do if you're looking at this review for another class, but that's what I would do. Okay, since I stopped myself, let's also look at this as we have a 364 square foot patio, and we can multiply by the conversion. 300 square feet costs $2,275. And with the unit conversion, we can also get to the final value. And now it's right, 2760. So whether you work it as a proportion problem or a unit conversion problem, unless you fat finger it and type in the wrong number in your calculator, it works out. Okay, question 8. You're doing some work in the house. Bob and Carol want to put a concrete patio on the side of the house to keep people from tracking mud inside. So you're in the backyard, you go through the patio before you're home, or you come into the driveway to the patio before you go into home. Just keeps the house a little bit cleaner. It's an 18 feet by 18 feet 8 inches by 6 feet 1 inch. So we have this patio shape. I'm going to make it a little bit different looking because I need to make a volume out of it. But this is 18 feet 8 inches, and this is 6 feet 1 inch. And we're going to fill it with concrete. It's 6 inches deep. So we're making a concrete slab patio. So let's work with 18 feet 8 inches times the feet by 12, add the 8. 18 times 12 plus 8. That's 224 inches. And the 6 feet 1 inch is 73 inches. And 6 inches. I've converted this so that they're all in inches. So I can go to the volume, length, width, height. This formula is also provided in your formula sheet for the test. It'll be part of your test. You don't have to bring it with you. In fact, if you do and you take it to the testing center, they will not let you use it. But then you'll open up your test and then you'll see it anyway. All right. Length, 224 inches. Width, 73 inches. Height, 6 inches. Let's see how many cubic inches this is. 98,112 cubic inches. Great. What do they want? Calculate the volume in cubic feet, rounding up to the nearest cubic foot, because the company only sells in whole cubic feet. All right, so we need to take our 98,112 cubic inches and convert it to feet. Well, I know 12 inches in 1 foot. And to make a volume conversion out of that, I cube it. And let's see what we get. 98,112 divided by 12 to the third. And we need to round up because they only sell in whole cubic feet. 57 cubic feet is how much we'd have to buy. Delivery cost is $7 per cubic foot plus a $50 surcharge for orders less than 100 cubic feet. So first off, $7 per cubic foot. A quick conversion would get us how much that it's going to cost for that part of the soil. But then there's a surcharge because we are ordering a smaller amount. So a $50 surcharge. There we go. Oh, I didn't do that one. There we go. Perfect. All right, we're almost done with this review. Question number 9. A bicycle is traveling at 16 miles per hour. How many feet will it cover in 30 seconds? All right, let's find out. In 30 seconds, the conversion factor that they give us is 16 miles per hour. So in order to use that conversion factor, we need to get into hours. So we start off by converting from seconds to minutes, and then from minutes to hours. Then we can use that conversion factor that with the 1 hour on the bottom and the 16 miles on top. And then we check in and they want to know how many feet. So we're not quite there. Feet. So we need to multiply by also, and this is in the conversion factors table. 1 mile is 5,280 feet. All right. For the units, we can see we went from seconds to minutes, from minutes to hours, from hours to miles, and from miles to feet. 30's on top, the 60's on bottom, the next one, the 60's on bottom, the next one, the 16's on top, and then finally the 5280 is on top. So everything on the bottom was preceded by a division sign. Everything on top was preceded by a multiplication sign, except for the very first number. You can't precede that with anything. 704 feet. No rounding. They do say 1 round decimal place if needed, which we don't need. Okay, final question, number 10. She wants to deliver a bunch of blankets, 83 miles. It'll take us 2 hours and 20 minutes to complete. And she wants to know the cost, total cost in gas. So I don't care how long it takes if I'm only interested in the cost in gas. So the 2 hours, 20 minutes is irrelevant to this problem. But the 83 miles is critical. That's what we're starting with. Now for our next conversion factor, we need miles on the bottom. If we look through the conversion factors, this one has miles in it. We need the miles part in the bottom, so that'd be 19 in the bottom and 1 gallon on top. Great, we are now in gallons of gasoline needed. For our next conversion, we need gallons on bottom, so we can reduce the gallons. And this is the next one. And it has gallons on bottom already per gallon, 1 gallon, and it's a cost of $3.29. The units reduce. Our final unit will be dollars, which is what we're looking for. And now we go 83 divided by 19 times 3.29 dollars, $14.37. Situational rounding for money, nearest cent, less otherwise requested, nearest dollar or etc. 1437. All right, I hope this review helps you feel confident with your knowledge and skills in your module 1 and 2, and you do well on your exam. All right, thank you so much.